All right.
Cool. Well, today I'm excited to have Neal Spackman on the show. Welcome, Neal.
Hi, Alpha. Thanks very much.
Cool. So do you want to share a little bit about how you got into the whole regenerative sphere and about
Oh,
your background?
goodness. Um, how far back do you want to go? Well, we'll start with I was I spent 2 years in Guatemala in my early 20s, and while I was there, became very, very interested in sustainability in food systems and sustainability in the built environment. I was acquaintanced with a group of corn farmers whose farms failed, and they kind of had to pick up and leave everything and move to the city, hoping to find a better life for their kids. And it kind of got me on a question of, well, why does a corn farm fail in Central America, right? Like what's all that about, right? And I was a doctor's kid. My dad was a cardiac anesthesiologist. Most of his siblings were doctors of one kind or another. So I always thought I was going to be a doctor growing up, but became deeply interested in sustainability in food systems and sustainability and buildings, right? Materials and all that kind of stuff. But I wasn't under the impression I could make a living doing any of that. So my undergrad degree was in Middle East studies and Arabic, and I did some economics work as well. And then those things all kind of converged when I was offered to be a co-founder at the Al Bayda project in Saudi Arabia. And so I was part of the founding team of this effort, and at the time we thought of it as building a green village. Um, and that went all kinds of different directions. And Al Bayda was funded by uh, Her Royal Highness Princess Haifa Al Faisal, who's the youngest daughter of the late King Faisal. And so for her, it was an effort at it. Her focus was primarily humanitarian, but we were working with tribes of settled nomads south of Mecca, and the project did all kinds of things. I mean, she got the government to bring the first paved road into the area so that people could have quick access to the city. She got the electricity department to bring electricity to these villages, so that they could have air conditioning and power and light. Um, Altogether, Al Bayda was involved one way or another in community development, education, infrastructure, and my role in that project was on the land, water, and economy side. Right, my role was work with the people and figure out a way to bring life back to highly degraded landscapes, in a way that it would bring nature back and allow re-enable people to make a living on their land. And this was located about 45-minute drive south of Mecca City, in the foothills of the mountains in the Hijaz. And so we averaged 60 millimeters of rain a year. We
Can you
super
convert that into
extreme.
inches for the
I think an inch is 25 millimeters, so two and a fraction inches of rain a year.
yeah, so very minimal.
Yeah, and that's the average, right? In deserts, averages don't count for much, because you'll go 2 years of rain, 2 years with no rain, and then in the third year you'll get like 6 inches in, over two different events. And they, right, so you'll have 24 hours of actual precipitation over 1,000 days. you know Averages don't count for much in the desert, but highly, highly degraded, just austere, extreme landscape. And I think that's what makes it so salient is that we took on um, something that many people did not consider to be possible, and proved that it was possible. And I think that's what people appreciate about Albela so much. It's not so much that, restoration is particularly unique, but it's that we did it in such extreme circumstances, um, and in a very comprehensive and holistic way that I think makes people appreciate and you know find an attachment to that project and what we did.
What was the
Uh,
background you had that they hired you for this?
I had already lived in the Middle East. I knew the language, I knew the culture, and then I had all the theory about how you do this stuff with land, but I didn't have the practice with the land. So, um, wisely, in my opinion, they picked someone with the social skills and the cultural skills rather than someone with the land ability, because I think culture is the linchpin. I think the socio-political economic aspect of this is actually much more difficult than the land piece.
Mm,
If you can figure out the socio-politico economic aspect of restoration, nature will fill in the gaps for you, right? The land piece is actually quite easy once you've got that other stuff figured out.
mm,
Well, and maybe easy is the wrong word. It's simple. It's simple. The complexity of this is in people, right? It's not in nature.
mm.
The nature part is rather straightforward once you're moving in the right direction.
What was it? Where did you get your theoretical background in how to do it from?
Um, I had done some permaculture stuff. I had a PDC, but then I had book knowledge of Nabatean water management, Incan water management, ancient agroforestry systems of the Negev Desert. I had read about all this stuff because I was super passionate about it.
Mm,
Um, the just polycultural agroforestry, agroecological systems, silvopasture. It was all stuff I had read about, and then it was a question of, okay, in the project itself, we did hundreds of tiny experiments, right, to try to figure out what would work for that context, and hundreds of tiny failures and a few tiny successes, and then we would build on the successes and expand on those. And in that way, we prototyped a way to reforest that landscape in a way that it would contribute to the economic well-being of the people, um, and put them back in a position of being stewards of those landscapes rather than the primary cause of degradation.
mm. And so what were some of the primary techniques that worked to restore the landscape there and the water?
What is largely called natural infrastructure or green infrastructure. We trialed gabions, check dams, Zuni bowls, one rock dams, Zai holes, air wells, fish scale berms and basins, lots and lots of different kinds of small earthworks to intercept surface flow in both in the mountains and in the dry river valleys and in the floodplain. We also did probably 4 kilometers worth of swales, between 4 and 5 kilometers of swales, if I remember right. Some of this stuff was, off contour. Some of it was on contour. Some of it was keyline based. Some of it was kind of the opposite of keyline. So those are the major tools we trialed on the water management.
So basically you had different ways of intercepting the water flow. So either it's like
Yeah,
the earth itself or rocks, or maybe, I don't know if you use sticks. And then
we didn't
basically
have sticks,
no sticks. Okay.
right? We had rocks and dust. That's what we
Okay.
had to work with.
And then you sometimes use that. So by on contour, just for listening, it means that on contours when the contour is the same height. So you
Yeah,
do when it's flowing perpendicular to the contour, or even on
yeah.
the contour itself.
And we had Jeff Lawton on as a consultant very early on, who, had significant experience with some of those. We had, I did a course in aquaponics to explore if aquaponics was a solution we could bring. I took Darren Doherty's Rex course and focused on some keyline stuff with Darren to try to figure out what of that would work. So where we felt like we needed consultants, we were able to bring people in who had that kind of expertise. We didn't do everything that they recommended, but it got us moving in the right direction pretty early on.
And so once you kind of slowed this water down and kind of gathered it, then did you then start try to build the soil or start planting, or what was
Yeah, so we manually planted trees, and we had about a dozen different species that we were trialing, half of which were native and half of which were not. And just trying to see, what will survive this climate, allow us to create microclimates and provide an economic output at the same time. Like those were the three major considerations we were looking for in the trees that we trialed. Whether, and on that economic side, it was whether, could it provide fodder? Because the culture there is still very much pastoral, right? All the people I worked with were camel grazers. They had camels, sheep, and goats, and a whole bunch of identity built around, the husbandry of grazing animals. And so very early on, we knew we needed a silvopasture was kind of the end goal of what we were trying to build. And then if there was anything beyond silvopastoralism, it was, is there a high value crop that we can grow that would give us, something to sell into export markets?
Can you define silvopasture for the listener?
Yeah, silvopasture it means tree-based grazing systems, right? So which are used to be very common and is a very standard kind of agroforestry. But especially in that climate where historically you would have a summer rain and a winter rain, right? They used to reliably get 2 rainfalls a year. They don't get that anymore. But in that climate, when it rains, you get this flush of greenery, right? You've got annual grasses where they will go to seed within 6 weeks, and then die very quickly. So you'd get a rainfall, you'd get 2 to 3 months of lush grazing, right? Of grasses and forbs. But then you'd have 3 to 5 months of nothing. And during those periods, historically, people would graze trees, right? So the pattern used to be you'd have 3 months of grass and then 3 months of trees and then 3 months of grass and then 3 months of trees. And that gave you enough throughout the year that you could feed your camels on that land, right? And there was a whole indigenous land management system that evolved to caretake the fertility and productivity of those landscapes. That system is called himma, which means protection or conservation in Arabic. And the himma system goes back at least to 1,000 or 2,000 BC, as far as we can tell. So that this indigenous land management system maintained the fertility of landscapes in the Arabian Peninsula for thousands of years, where it was very closely and very tightly managed in terms of what time of the year could you have what types of animals with what kind of intensity grazing that land. And so in some sense, our project was aimed at restoration of himma and trying to supplement that with potential tree-based cash crops.
And what were the you said there's more difficult the social part.
Yeah.
What was the difficulties there, and how did you overcome them?
Well, from the project perspective, it was gaining trust. That if you want to have successful restoration of land, right, and ecosystems, you know, and the assumption was I wasn't going to be there forever and that the project would have an endpoint, right? But that we would foster the reestablishment of these sustainable land management systems, and that people would be educated to practice them and continue on in that. That was the long-term vision of what we were going to do. And that's inevitably there's social engineering in that, right? And so gaining trust was absolutely the first objective there. Is people got to understand that, you know, we're not here to take advantage of them, that we're not trying to, you know, take things away from them, and that we need them to be willing to work with us, right? To bring their knowledge and their, well, it's traditionally called tech, traditional ecological knowledge, right? Or traditional indigenous knowledge. Sometimes it's called TIC, right? But we knew that there was information and knowledge that they had about these lands that we didn't, and that it would be necessary in successfully reestablishing these systems, right? And so building trust was absolutely the first thing. And it seems trite to say it, but the way to build trust is to be trustworthy, and to prove to people that you are, and that just takes time. Second, it was, I think, understanding how bringing ecology back to a landscape could fit within the dominant culture and practices of the people who were there, right? And making sure that we weren't imposing something, but rather working with the local folks. And restoration is not quite the right word for a socioeconomic system here. Yeah, I mean, the idea was to build on what had been the indigenous economy, but to improve on that. And so it was building on that indigenous knowledge to create something that would allow for indigenous economies to come back, but to in a way that it fit the political context that they found themselves in and the economic context that they found themselves in. And so that's, restoration's the wrong word for that. But it's akin to restoration. It's more like revitalization or something like that. And so again, that means deep cooperation, right? It means, and you can't do that without trust. Interestingly enough, some of the considerations that I have found to be very difficult since El Bela were actually quite simple in that context. So for instance, the land tenure, we were granted a 100-acre valley, you know, small enough that it was doable as a prototype, but big enough that we knew it would be relevant, through the governorate. And once that was established, there was zero red tape in terms of what I could do on the land. I had absolute free reign to experiment. Never had to get a permit for something I was trialing. Never had to go to a bureaucrat and say, hey, we're going to do this next. And then for them to go and research and try to find a permit. None of that. and I have since learned that that is extremely unique. And so in that sense, it was actually much easier to investigate and experiment on regenerative land systems. I mean, you could never do that in California, right? I had more freedom in Saudi Arabia than I ever would have had in California to try to develop new regenerative land systems, which is in some ways ironic and other ways not really. But I think that's a very unique aspect of the project was that because of who our patron was, because of Princess Heifa's willingness to champion and lead that project, it actually simplified a great deal of things that in other contexts are almost insurmountable.
Mm. And what were the results ecologically of the project?
So last year I published an article on LinkedIn where we took satellite data from the site, measuring what's called the NDVA, the something differentiated vegetation index, DVI. Right? I forget what the N stands for, but essentially this is satellite data that's measuring photosynthesis on a given area. And so we took the polygon of our site and sent those coordinates, put it through this satellite data. And this is with the help of a French scientist named Cedric. So shout out to Cedric for helping me figure this out. But the graph is the article is on LinkedIn if you look me up. But what it shows is that you can see rainfalls, a couple rainfalls before our system was done. And you can see that the land's response to that rain is almost nil. Right? Like you get a tiny blip in increase in vegetation, but really not very much. Whereas now you can see the rainfalls, and you can see that the land's ability to absorb and put that water to work in creating life is drastically higher. And even though we stopped work in 2016, it is getting greener every year. Right? It's there is more and more vegetation, more and more life on that site every year, even though we're not doing any maintenance on it and haven't for 8 years.
Mm.
At some point, it will reach an equilibrium. But are you familiar with ecological stable state theory?
Yeah.
Yeah. So there's the idea that when an ecology hits a stable state, it's like a marble sitting in a cup. And there's a slope on it. And if you push the marble to the outside of the cup, the marble falls down and you get this lower ecological stable state that's highly degraded. And what we did was we pushed that marble up the hill and got it back, and now it's moving up on its own, and at some point it'll stabilize at a higher order of ecological function, where the rainfall that falls is more effective, to borrow Alan Savory's term on effective rainfall. And the land is able to absorb that water and funnel it into biological activity. And we experienced some of this while I was there. I mean, we watched the whole trophic cascade in reverse come back to the site where, the first things we noticed after a rain that was different was we had a bunch of mushrooms come up, right? Including some species that the local men had not seen in some time. So there were indications that the mycelial layer was reviving.
Mm. Did you have to initially do any inoculation with mycelia?
No,
So
we
you
didn't
never
do
did
any.
anything with the soil? Okay.
Nope, no inputs at all. Just fix how water interacts with the land.
Okay.
And some manual planting.
So nothing like a composting or vermiculture with worms or any.
We did some very limited composting. We didn't have the water to compost or the green or brown material for it.
Mm.
right? Like to really compost, you need a lot of green and brown matter. We didn't have any of that. You know, we had dust. We did compost a camel for education's sake. There was a this is a weird story, but there was a camel that had been hit by a car and he died, and the carcass laid on the side of the road for 2 years. Like, it didn't biodegrade.
Wow.
That's how dry it is that animal carcasses will just be there and not, right? If a camel died in the rainforest, the whole thing would be gone within 2 weeks, right? Right. Maybe you'd find a jawbone lying around somewhere, but the scavengers would come, the biodegraders would come, the fungal would come, right? And you wouldn't have a carcass. But where we were, because it's so dry, there's no biodegradation. And this is true of woody material and of animal carcasses, right? If you just leave it alone, it doesn't biodegrade. Like, it was like you could have made leather 2 years later with the skin.
Mm.
And so my workers kind of hated me for making them do this, but we scooped this camel carcass into the back of my truck and we took it to our demo site and I composted it and taught them how to compost in the process. Right. And within a few weeks, the carcass was gone. Like, the hip bone was still there, the jawbone was still there, but the rest was composted. And the point was, biodegradation in this landscape isn't happening on its own, right? The mineral cycle is so broken. And that means that affects plant life, that affects animal life, it affects the water cycle, right? And so this was partly my own learning as well, but it was like, okay, the water cycle's messed up, the mineral cycle is messed up, and unless we find a way to nurture these things back into health, you're not going to get ecological rehabilitation. You're not going to get ecological function because these two cycles are so out of kilter, right? And so that was not, we did not do any large scale composting. We did not do any kind of inputs into the soil because it was too expensive at the scale we were. Which is maybe an interesting data point for other folks, but for us, I was like, well, we don't have we don't want to spend the money on that. We just want to see if we can get, if we just fix the water, is that enough? And it was. Now maybe we could do it faster if we did use those inputs. I don't know. Maybe, probably, but we didn't do it. We didn't do it. But yeah, we saw the fungi come back, and then plants and insects started to come back, and then birds and lizards started to come back, and then mammals started to come back. And within 4 or 5 years, we had predators on our site. When there, I mean, there weren't even ants when we started Alpha. It took 3 years for ants to show up on our site.
Wow.
You know, and I didn't even notice them until the first time I saw them, and I was like, wait a minute, there's ants here. And then I realized, how come there haven't been any ants here the whole time up to this point? Like, their absence did not affect me until I noticed that they were there. Right? Like they're a ubiquitous animal, right? They should be pretty much everywhere. They weren't where we were until 3 years into the process.
Hmm.
And it's I wish everybody could experience that. There is nothing so satisfying as bringing life back to a dead place. It is a beautiful, sublime experience.
Yeah, so it's almost like you do the water system, then you plant some stuff, and then it kind of takes care of itself because of the feedback loop that you pushed over that hump. But now it's building more vegetation, and that also brings in different forms of wildlife and biodiversity. So So you've set in motion the kind of rewilding system
That's it.
to run on its own, kind of.
That's it. We gave it enough of a push that Mother Nature said, okay, we're gonna recolonize this place.
Right.
And that it's pretty amazing. It's pretty because the cascade gets faster as time goes on. And for me, that culminated in 2020 when I went back and got my after footage for that video. So I'd been out of country for about 2.5 years. I didn't know what had happened. And it hadn't rained for 2.5 years. And I knew that some of the trees we had trialed were dying, like some of the species died off because they couldn't make it without irrigation. And we cut the irrigation on purpose and said, okay, let's see what's actually going to make it to actually live in this ecosystem as part of the ecosystem. And that was 2016. I left toward the end of 2017 and then didn't get back until October, November of 2020 or 2019, I think. And it was just this amazingly lush green landscape where it had been dust and rocks before.
Right.
And now that's not to say that we didn't shift the latitude of the place. It's never going to be a rainforest, but it's at least back into a position where there's a wet season and a dry season, and when it is the wet season, it actually is quite green, right? All kinds of species of ground covers and trees that are native are coming up on their own now.
And do you see? I mean, it's probably not quite enough to impact to make the rain, but is the rain still coming 2 times a year around the same amount, or is it shifted a little bit too?
No, I don't think I think you need thousands of hectares to shift
Right.
that.
Okay.
I don't think we're big enough to do it. The fundamental question you're asking is, how many microclimates does it take to create a new climate? And I don't know if anyone knows the answer to that.
Well, it kind of depends if you're in a valley or if you're in the flats. So yeah,
absolutely.
I think you do need thousands of hectares. And your size scale was how big?
100.
100. Okay.
100 acres.
Yeah.
So 50 hectares. Or 44 or whatever the number is.
Yeah.
But we did create the template for growing those microclimates.
Right.
Right. Which is the first step.
I was wondering. Oh, go ahead.
Yeah. I think doing it at scale, I think the Saudis may go forward with doing it at scale, in which case we may be able to answer that question of how many hectares do you need to do before you start seeing the rain come back?
Right. Actually, I think it's probably more like 10,000 hectares. There's more. Yeah.
I don't know.
Right.
Yeah. I don't know if anybody knows.
Well, there have been climate models in different areas.
Yeah. Well, you know what they say, all models are wrong, but some are useful.
Yeah.
The modeling probably points to a number, but I think we got to do it in real life to really find out.
Well, there is in Europe this guy Ronnie Meyer who I just wrote about. They tracked in Europe the rainfall kind of near where there was farms and where there were forests, and when they're near each other. And so they could actually show, by taking about 1,500 of these data points, that nearer the forest there's more rain than where it's nearer the farms, because so
I think we've known that for a long time, though. Have you read David Montgomery's books?
I read a little bit of Dirt, not very much.
Dirt's one of my favorite books, but
yeah.
if I recall correctly, he's got a quotation from some of the early American colonists saying that they explicitly wanted to dry out the climate because it was too wet, so they would cut down forest and put in fields.
Mm.
And at some point that switched because the phrase "rain follows the plow" came out of somewhere, and we learned it was the opposite, that the plow kills the rain eventually.
Well, I do have a theory about that. I don't know if it's true or not, but I think when they first came, they plowed it, and so that actually released a lot of fungi spores into the air, which then
Mm,
possibly seeded rain. But then if you keep plowing, you destroy all the fungi and you destroy the other things so that they can't see the rain. And yeah, you destroy the evapotranspiration. And
yeah, yeah,
so I was wondering if we could ask you a little bit about Iberia and how
yeah.
we could
Let's do it.
restore some of Spain and Portugal.
Let's do it.
Yeah.
I mean, my experience in Iberia is mostly in the south. I've spent some time in Cadiz. I'm in love with the dehesa and the montado system, right? The traditional, the cork, oak, and pork food system.
Yeah, the Dehesa is agroforestry. Uh,
Yeah,
you
one of the most beautiful indigenous food systems of Europe, and produces really delicious food. Um, that's that's the bulk of what I know about Iberia. I also know that it's very sparsely populated, right? You've got large areas that have very, very low density of people. But those landscapes that have been farmed for a long, long time, right? And so I know of a cooperative of rice farmers in Sevilla along the Guadalquivir River, for instance. And the Guadalquivir is interesting because it flows into the Mediterranean, but the tidal movement is so high that and the reduction in freshwater flow means that the when it's high tide, the salt water will reach 100 kilometers upriver. And that's absolutely decimating, the productivity of the rice farmers and the other farmers who traditionally could pull water out of the river to irrigate their crops, and now they can't do it anymore because it's too salty, right? If they were to try to irrigate with the river, they'd kill their farms because of the high salinity. And so you've got this there's this supply and demand question of fresh water where they've depleted the supply so much and increased the demand so much that it's killed the function of the water cycle. And the effects of that are really quite predictable. You've got falling productivity in many different regions. And when I was there in Seville, I took photos of the rice farms because over half of them were fallow, right? They hadn't planted anything because they just knew that they wouldn't have enough water to grow it. And of course, when you have a fallow field, it's just open dirt baking in that Mediterranean sun, right? There's no biology in that soil anymore. They're killing the soil because they can't irrigate it anymore. And at the same time, they're rice farmers. They want to grow rice. So, heavy water usage crop. And um, a real difficulty in figuring out how to adapt to these new circumstances where you don't have enough water to grow rice anymore. You can't pull water from the river anymore because it's too salty. And what's the adaptive system or the regenerative system that allows us to reverse that degradation, both of soil and of water and of agriculture and of ecologies, right? It's this crazy mix of things. So my understanding is most of the Mediterranean is in a very similar position where water resources have been highly degraded. Rainfall is becoming intermittent or less predictable and typically falling at lower than average seasons. What I don't know is how much of that is due to macro patterns, How much of that is due to land use patterns? There's some split there, and I don't know what it is.
And what would you say the solution is? You have some solution for what the rice farmers can do?
Yeah, those rice farmers need to develop a salt marsh agroecology.
Mm.
And I helped set up a project there there's a group called Seawater Solutions, run by a fellow named Yannick Nyberg, where we've collaborated with them on a number of projects, but they're doing a marshland restoration and also trying to foment the use of saltwater crops. So there's a group of plants called halophytes, which means salt loving, I believe, or salt growing. But these are terrestrial plants that grow in salt water, and there are thousands of halophytes. But there are a couple dozen halophytes that have cropping potential, where we could either grow grain or animal fodder or chicken feed or fish feed or industrial inputs or vegetable oils. And I would think salinization of soils is also a huge global issue, right? That's not just the Mediterranean. That's all over the world. And I believe that halophytic agriculture is among the most powerful adaptations we could create, because salt water is infinite.
So you're saying if you create these marshes, plant trees next to it, then you can grow rice paddies next to that?
Not at all.
No,
I
no.
don't think these farmers will ever grow rice again.
Okay.
I'm saying there are crops that grow in seawater that these farmers can farm, where they'll still make a living farming.
Okay. What would these crops be?
The most well known is called Salicornia, which is also called sea asparagus or sea beans. And Salicornia, the farming of Salicornia was developed by a scientist named Carl Hodges. But Salicornia as a gathered plant has been used for thousands of years, right? The Romans called Salicornia glasswort because they used it in glass construction. But Salicornia has been used as a gathered food for thousands of years, and around the world, in the Mediterranean, in Latin America, in Asian countries. Coastal communities have been eating Salicornia for a long, long time. But farming it is a fairly recent development and was developed by Carl Hodges and Ned Doherty in the 1970s at the University of Arizona's Environmental Research Lab. And I'm writing a number of articles about this, but seawater farming, Salicornia is the most well-known crop, but there's also Disticlus, which is a grain crop from the Gulf of the Colorado River. There's Sarcocornia, which is a perennial. There's oyster leaf. There's lots and lots of these plants that are not at all well known, that can be farmed, that have significant utility in terms of nutrition and taste and application in different markets. But it is an industry in its infancy, is seawater farming. But in terms of coastal areas where soils are salinizing, right? And that's all over the planet. It's the Gulf of Mexico, it's the Mediterranean, it's lots of different areas in Africa, lots of different areas in Central Asia and in Southeast Asia. I think these are a major solution to food security and to salinization of water resources. In some contexts, I think where we do these saltwater farms as an agroecology, I think they can also recharge the small water cycle, because these coastal areas is where so much of this disruption happens, because you've got evaporation coming off of the ocean, but highly degraded coastal ecosystems, whether we're talking about mangroves or marsh or coastal forest, they're often highly degraded and that interrupts the function of the small water cycle. So I think it's my opinion, because I don't have the science to prove this, but it's my opinion that coastal rehabilitation, whether through agroecology or just straight up restoration, is one of the key steps in restoring small water cycles in places like the Iberian Peninsula.
Yeah, I would agree with that. Mian did a study, and he was looking at Valencia, which is very similar in nature to Andalusia in southern Spain. But basically, the sea breeze comes in, and it goes over the marshes, and the marshes both cool it and evapotranspire to add to quite a bit of water vapor. And then it blows further inland, and then the shrubs add some evapotranspiration, and because it gets hotter, because it's been chopped down, it gets hotter there, and then it rises and it creates rain if there's enough evapotranspiration and if it's cool enough. Otherwise,
Yeah.
hotter air, holds more water vapor. And so he's saying that it's the destruction of a lot of the coastal marshes and also the shrubbery in the forest that's leading to that loss of the summer storm. So yeah, so I think because I think they've been draining a lot of the marshes in, say, Andalusia. So how do we bring them back? So you're saying that, yeah, I think this is a great solution, that you can kind of create these crops around it. And
yeah, so I've been with a group of partners. So I mentioned Carl Hodges. Carl Hodges was founding science officer of a company I formed in 2019 called Regenerative Resources. I've partnered with the pioneers of this saltwater agriculture system. And we've been focused on mangrove agroecologies for coastal areas in tropical and subtropical regions.
which country?
Well, right now we're raising for a project in Mexico. But this is relevant all over the world, in subtropical and tropical regions. So we've done work in the United Arab Emirates. We've done work in Saudi Arabia. We've done work in Egypt. We almost got something going in Namibia, but it faltered. But at the moment, we're focused on Texas and Mexico, with an eye to building some scalable commercial systems. And then from there, it's tens of millions of hectares globally where this system's applicable. With a focus on a mangrove-based agroecology. For the Mediterranean, it would be a marsh-based agroecology. There's still high value things you can grow there in a way that you're getting a lot of those ecosystem services back, a lot of that ecological function back. But it's not a restored ecosystem, it's a managed agroecology where you have economic output and job creation, justifying the cost of that kind of rehabilitation, right? And so Yannick's doing some of that work in Spain, working on a marsh-based agroecology. We've collaborated with him.
Which part of Spain?
In Cadiz.
Okay.
So in Cadiz, or north of Cadiz, there's a big national park called Doñana.
Yeah.
It's a big wetland, which is quite threatened. It's been drying up, and I think it's Doñana, but
it's Doñana. Yeah, the Spanish government, I think, actually invested $1.4 billion to get the farmers in the neighboring regions not to use up so much water, so that the wetlands in Doñana would survive.
They may have, I don't know. But I do know it's the largest preserved wetland in Europe. And there's lessons to be learned from that, I think, for the rest of the region. So there's that coastal area, right? You need, and you've got to address the conflict between economy and ecology, which is why I think agroecology is the way forward, right? Because if you just tell people, hey, look, all the coastline is now reserved because we need water, you're never going to get that through politically. People want to live on the coast. People want to use the coast for development, right? They want to be able to fish. And so And at the same time, you need ecological function in these areas. And the only way you marry that is if you approach them together. And that's what agroecology allows you to do. Right. So you can't say, we're going to destroy this part of the coast and allow for, we're going to build cities here and hotels and, let people do whatever we want. And then I think that pretty typical. We're going to conserve this part and not allow for any exploitation of any resources. And we're going to destroy this other part where we grow our economy. My opinion is that that's a failed approach. That you need to address economy and ecology together. And agroecology and regenerative urbanism and that kind of smart design allows you to do it.
How did you bring in the money for, say, the Mexico project? Is it investors or is it the government sponsoring it? Or
we haven't yet. No, we're raising for it currently.
Okay, but it's you're trying to get investment as opposed to government funding.
No, we're going after grants first, and that will lead us to something that's investable.
Okay.
Right. The intention is to have something investable, and I mean less than 1% of philanthropy goes to environmental causes. Right. Like if we create something that's going to rely on philanthropy eternally, we're never going to solve these problems. Right. Whereas if we can appeal to the, $6 trillion sloshing around capital markets, if we can appeal to people's greed and make something investable, then there's an unlimited, fountain of capital that we can access. And so that's always been the intention, is create something investable, and then we get a financial flywheel to go out and solve these big problems.
And so what's the reason they would investing? Is it this land gets resold, or what happens? Or
no, the reason they'd invest is because they make money.
How do they make money?
Right, but there's a couple different models we've played around with. Right, one is kind of a real estate model where you're acquiring degraded landscapes that other people don't see any value in. And in the rehabilitation of those landscapes, you get a tremendous increase in the value of that asset. That's one way to do it, which is essentially a distressed asset play.
But that means you resell. You don't resell it. You just raise the value of neighboring land.
Yeah, and then you buy out the investors. Yeah. Right. They could resell their portion in it.
Mm-hmm.
But the split is between it's called an opco propco. Right. You have an operating company and a property company. Right. The operating company owns a portion of the project and the property company holds the asset. And the property company can sell the asset to whoever they want at whatever time, but the property company actually manages it. Right. And that's a way to give people an exit, give people a return, but it's actually the management of the land that stays permanent.
Mm-hmm.
Right.
And what's the incentive for someone new to come in and buy it from the original investors?
The same thing and that would be my role, right? That would be my company's role, is we put the deal together. We're the management company of that property. We own a piece of that change in value, right? And we also own the revenues off of operating that property.
Mm-hmm.
Right. So that's one way to do it. You've got and that's fairly typical real estate stuff. The opco propco split, the change in asset value, that's all quite conventional. And our intention with that was to make something where people are like, okay, yeah, I recognize this business model. It's being applied in a new way with regenerative systems that I don't recognize, but at least the foundational idea of it is very recognizable and very successful in all kinds of other contexts.
Right. Yeah, I think I met someone who was trying to start some kind of bank that would fund this kind of land restoration because it's basically increasing the value of the land.
Yeah. So that's a very conventional way you could do it. And we tried to do that for a very large project in Mexico. We were going to purchase 30,000 hectares of land on the coast, and which is, it's completely degraded. Like there's nothing living on that land. There is not a single element of photosynthesis on this piece of land that we scouted. And it was huge, right? 30,000 acres is 4 times the size of Manhattan Island.
Yeah, it's enough to bring back rain.
Yeah, it would have been enough to bring back the rain. And had we funded that project, we would be 5 years into it. We would have grown a few million mangroves by now, and we'd be measuring the delta, right? We were unable to fund that at that time, and so that project has been shelved for now. But there's other ways to do it. But I do think the real estate version is quite appealing, right? And you could do that over and over and over again, in many different countries. And the seawater ag aspect of it and the agroecology ag aspect of it is really quite appealing, because seawater is infinite, right? If you can create a system that runs on seawater, then it can last forever, right? If you don't care about the rain or freshwater resources, if you just got to pump seawater up, and if you can justify that expense financially by, creating value on that land, then it can functionally last forever, without any reliance on freshwater resources, which is that's really quite a game-changing thought. And so that was the idea, is that if you can take these dead coastal lands and make them green and lush in a profitable way, just off of what you're producing, right? In a farming sense, there's all kinds of enterprises you could stack on top of that. You could stack ecotourism on it. You could stack medical tourism on it. You could build whole cities based on that concept, which no one's ever done before. I don't know if I'll ever get there in my lifetime, but I'm really intrigued by the idea, and I'd love to do it. But that's where it's getting a little bit beyond the scope of the discussion, and a little bit beyond Iberia, right?
Mm.
But those coastal ecosystems are absolutely critical, in my opinion. And then once you're uphill of those, right, you're getting into the interplay of deforestation, desertification, and drought flood cycles, right? And if you have forested hillsides, then when it rains, you don't have a lot of erosion, and you've got an ability to capture that water and slow it down, right? But if you deforest those hillsides for agriculture, which is what the Romans did in Italy, by the way, then you get drought flood cycles. You may get the same amount of rain early on, but the biological structures to manage that rainfall are not there. So you get massive amounts of soil erosion. You get big floods that become destructive because the land cannot absorb that rain and put it to use, which is what we call ineffective rainfall. So if we plow land, if we deforest land and convert it to agriculture and then plow it year after year after year, right? And parts of Iberia have been farmed for what, 1,600 years straight? Something like that. Then you lose the ecosystem function to manage, to be able to retain and put that water to use. So drought flood cycles always follow deforestation. I don't know of any exceptions to that rule. And that just means that your rainfall is more intermittent, it's less dependable, and when it does come, you're not able to actually capture it and put it to use, and it's destructive. And we see this in cities in the desert all the time, right? Mecca floods every time it rains, right? And the governorate of Mecca has spent billions of dollars trying to create a flood management system. The problem is what that flood management system does is it shunts the water into the sea as quickly as possible, right? You see the same thing in LA, right? The LA River used to be a thing, it used to function, and the flood management system in LA just gets the water into the ocean as quick as possible because they don't have the wherewithal or the ability to design a system that puts that water to use in growing life on the land. So they're just like, get rid of the fresh water that comes as quickly as possible because then there's less destruction to the infrastructure. But also you've uh, incapacitated the land's ability to foster life because we're getting rid of the fresh water that comes, right?
Yeah,
Uh,
LA could have been a lot more lush. I mean, I think Beverly Hills was at an intersection of rivers, and there was a lot of wetlands in LA, and
yeah,
yeah, it was artesian
it
wells and
could be a lot more lush, but instead they're getting
fish.
rid of the
Yeah,
fresh water as quickly as they can
right,
as a flood management system, right? And it's hundreds of millions of dollars in infrastructure investment that with a different approach and different design could actually green and cool the city,
right, and
right?
probably have an impact on fires because you have more humid winds
A major impact on
and
fires.
groundwater. Yeah,
Yeah, right. And so the thing is that municipal administrators, right, and most engineering firms operate in silos, right? Like, how can you ask the cityscape design guy? The people who build roads don't think about how this road is going to interact with water, right? They're just like, well, the code says put in the drains this often, right? And the people in charge of managing flood, they make a lot more money building a lot of infrastructure than they do trying to put something together that's going to rehydrate the mountains that are 100 miles away.
mm,
Right? Like this integrated thinking and this integrated systems design is not practiced and not at all intuitive to folks who just want to get a job done and get paid.
right,
Right. So it really does start at the design level of how are we creating cities and landscapes that interact with the water cycle like that's it's a question too far for most folks right now, but it is the right question to ask because otherwise we're just going to dehydrate our landscapes, cause drought and flood patterns, and then we get the forest fires and the degradation and the loss in agricultural productivity and the poverty and the rural to urban migration, et cetera, et cetera, et cetera.
right. Yeah, it's so connected. Like this
It's
whole
all connected.
flood fire cycle. Yeah, and it's particularly prevalent in, I think, certain latitudes. So California and Spain and Iberia are particularly susceptible to this because
Yeah.
in that amount of uh, precipitation or evapotranspiration that creates precipitation, that yeah, so that shift in amount of evapotranspiration affects the rain.
Yep.
Yeah, and then and right now in Iberia and same in California, there's all these fires, and that's making this whole restoration effort difficult too, right? Because
Yeah.
burning
You
down a
you
lot
get
of
this
fire as you're trying to restore everything.
you get this very destructive positive feedback loop.
Right. So in some ways, like just the same as the you in Saudi Arabia, the key is to restore the water cycle first. So if
Yeah.
we kind of restore the wetlands, the marshes, and the groundwater, so there's enough water for all the vegetation, but that also is a insurance against the fires because everything's a lot more hydrated.
Yep. Yep. And so and you kind of have to start at both ends and meet in the middle,
Mm.
right? You got to start at the top of the watershed. And I think the other place you start is on the coastline.
So
And then,
Sierra Nevada in Andalusia is kind of higher up. Do you have anything to say about that region and the restoration?
yeah, I mean, I don't know enough details, but in general, the catalyst is deforestation and agriculture,
Hmm.
right? And the the reforestation and the starting point is actually land tenure, right? And politics. You've got to get permits and governments to approve, to catch the vision, and then they got to work with you, and they say, oh, well, normally, we only allow for X, but because you guys are doing this big holistic thing, we'll allow for Y, but then once the politics are through, you're starting at the top of the watershed, slowing water down, right? There's a really beautiful USDA study on natural infrastructure that was done in Arizona, where they built this natural infrastructure to manage flash floods and did a 30-year study, right? So it's the most comprehensive study I've ever seen of the long-term effects of this kind of stuff. And they have increased the total amount of water in that watershed by 30%.
Wow.
Right? The water in the ground, the surface flow, the water in the life, it's 30% more than in the watershed next door where they haven't done any work. And so there's this idea that if you slow the water down, you're decreasing the amount of water downhill, right? Because you're capturing it all higher up in the watershed, and the people downstream are going to have less. It's not true. The people downstream get more because you've rehabilitated a functioning water cycle. Right? It's not at all intuitive that if you retain more water higher up in the watershed, that the people downstream end up with more water. But that's what the science shows.
Right. Yeah, you kind of need systems thinking. You can't just look at one variable changing. You got to see how everything kind of fits together.
Yeah.
As a complex system. Yeah.
But that study is really well done. I think there's over a dozen published papers related to that study that were all done in Arizona. But it's some of the most important science done on this stuff, because it shows that you're actually increasing the resource, right? You're increasing the amount of water.
So there's a bit of education that needs to be done, like even for the governments and others to agree to it. Say in Sierra Nevada, we'd have to kind of educate that there's multiple functions, right? The restoration, both for the flood prevention, but also for bringing back rain and snow.
Yep.
How did it work in the Great Green War in Africa when you was an advisor for that project, right? Is it kind of?
I'm an advisor to one of the many organizations involved in the Great Green Wall. So I'm an advisor. They're called the Frontline Organization, and they're operating in Gambia, Senegal, and in Somalia. So they're kind of on the extremes, right? They're on the coastal extremes of the Great Green Wall. And that's why they call themselves Frontline. And it's a work in progress, but you've got a lot of similar dynamics. You've got the addition of potential conflict between pastoral peoples and farmers, right? Because the nomadism of pastoralism makes it less predictable, and they're kind of a dynamic element in that whole thing. And I mean, conflict between pastoralists and farmers is at least 8,000 years old.
Yeah.
Right. That's an old pattern that you've got to design for and accommodate for. But in some of these projects, you have a similar problem with the salinization, where deforestation led to greater salinity of the rivers, which has led to salinization of rice fields, which has led to collapse of agricultural systems, which has led to, again, the rural to urban forced migration, the Africa to Europe forced migration, deforestation and drought flood cycles, desertification, soil loss, soil erosion, and rural collapse. Like exact same pattern, different ecological context, because they're tropical. They do have mangroves instead of marsh, right? But they've also got a much bigger palette of stuff they can grow, right? Like in Spain, you've got your citrus and your almonds and your olives, right? That kind of prototypical, archetypical Mediterranean agricultural setting, right? And the wet, dry season. And something like, 250 to 600 millimeters of rain a year, right? Whereas in Africa, we're looking at up to triple that amount of rainfall, right? And all kinds of crops and agroforestry systems that could be developed. And so
So it's
there,
not lack of rain around the Great Green Wall that's a major problem.
if you go further inland, it is.
Okay.
It becomes more of a challenge, right? But we know what the right systems are to implement. The barrier is not what do you do with the land. We know what to do with the land. The barrier is politics and finance. But in Gambia, for instance, we spoke with a number of tribal elders about trying to create a baobab-based agroforestry. There's been a lot of clearing of baobabs in West Africa for things like cashew plantations, which do well, but actually they're kind of like the tree growers in the Central Valley of California. Like they consume enormous amounts of water, and are draining freshwater resources to grow them. Right. And this is an interesting point of conflict, actually, because on one hand, we're saying we need to get agroforestry back onto the land. And on the other hand, we're saying, well, this particular agroforestry is actually inappropriate.
Right.
And the difference is the precipitation shed, right? If we're doing cashew plantations in Gambia, we're increasing the amount of evapotranspiration, but we're not seeing the local effect of that, because that's part of a precipitation shed that goes thousands of kilometers away.
Do you want to just define precipitation shed for the?
Yeah, I don't know if I can define it all that well. Precipitation shed is a hydrological map of where the water in the air coalesces into clouds and rainfall in a given area. Where are all the places that water can come from? Right? So for instance, where you are in Oregon, the Gobi Desert is actually part of your precipitation shed. Right? There's dust from the Gobi Desert that forms ice nuclei in clouds above Oregon. Right? So the precipitation shed of Oregon is enormous, right? It stretches all the way across the Pacific Ocean, right? Whereas the precipitation shed in where I was in Mecca is tiny and is actually a closed loop, right? So you have open loop precipitation sheds where if I'm evapotranspirating off a tree in a given area, that may contribute to rainfall thousands of miles away, but not necessarily rainfall where I am right now. Right? Whereas in a closed loop precipitation shed, if I'm evapotranspirating in a given area, I'll feel the local effects of that through rain somehow on my ground. Right? And so this gets into all kinds of interesting things. So for instance, have you heard of the third pole?
No.
Third pole refers to the glaciers in Pakistan, right? Where there's so much ice there that it's called the third pole. You've got the North Pole, the South Pole, and the third pole, because there's so much ice and snow in there in those glaciers. And I believe it's Pakistan and I believe the Himalayas, right? And I was part of a group that was trying to get reforestation in Oman happening because it would contribute to refreezing of the third pole in Pakistan. Because Oman and that Gulf of the Indian Ocean and the Straits of Hormuz is actually the furthest extent of the precipitation shed of the third pole. All right. So there's this idea that if you reforest Oman, and follow that between Oman through Iran and into Pakistan and the Himalayas, you'll start to reestablish and refreeze glaciers that are otherwise melting. Okay. So that's one application of precipitation shed science. Okay.
Right,
So
which
that,
brings to the mind that there's certain acupoints on Earth which are more powerful to eco-restore first, the ones that are a bit more upwind, that can bring rain to downwind places that really need them.
yes, it does. It contributes to that idea. I don't know if anyone that's ever been like, here's the acupoints of Earth where we really need this to bring water back to degraded places. That would be a fascinating study to do.
Yeah, it would. I
I
think
have no
it'd be a
idea
very
who would.
useful map because it's like
I
this is
don't
where
know
we
who
want to
would
put the
fund that study, but it is a very interesting question.
Well, yeah, and so for the Great War of Africa, like I would think Congo Forest maybe is one of those acupoints because if you can increase that amount, then more of that rain would, or evapotranspiration would get to the Great Green
You
Wall.
would think so. I don't know. I don't, because you're looking at like wind patterns and mountain ranges and rain shadows and you know what drives those patterns, and that's macro stuff, right? It's Hadley cells, and it's yeah, it's a lot of integrated science that I bet someone has the ability to map, and could probably harness some AI to try to model it.
Mm.
But
Yeah.
it's a maybe you should do that, Alpha.
Well,
Maybe,
I am kind of
maybe
interested. There's this guy Van der Ent and I think Root. So they did this map of the small water cycle. These Dutch hydrologists. So it
Mhm.
kind of shows where evapotranspiration comes more and then where it comes down more. So say in Europe and Asia, there's a bunch of evapotranspiration comes from Western Europe that kind of ends up, I think, in China. And so it's kind of like,
Yeah.
so it's a basis of kind of forming treaties where you get countries that are upwind kind of influencing countries that are downwind kind of.
Yeah. Yeah. I don't know if the science is not well enough established for politicians to bicker over that yet. Right?
Uh,
They're
I think
bickering
we
over
it's good
water
to
in
kind of
other
get it.
ways.
It's good to get it in motion because then we'll actually get more funding into that kind of
It'd be
science.
good.
Yeah.
Yeah, it'd be really good. It'd be really good. But then we're talking about like geoengineering, not in like a let's throw iron in the ocean or let's cloud the sun sense, but geoengineering from a very regenerative and ecological health lens.
Yeah, I mean, it's so restoration based. I wouldn't even call it geoengineering. It's just restoring
Yeah,
land to get more rain in certain
yeah.
places. Oh, just go back to the Great War, China, Africa. Like, what's the sequence there? Is it also the same as in Saudi Arabia, where you're basically trying to restore the water first, and then plant the trees, and then the soil comes
It's
back, and the
really
wildlife?
location specific.
Hmm.
Um, it's really location specific, and there's a that's where I really appreciate kind of the design aspect of permaculture, because it gives you a lens to try to say, okay, what's the limiting resource? The in some places the most important thing is security, right? You can't plant trees or expect people to plant and tend trees where you've got, roving bands of marauders that are kidnapping people and wreaking havoc, right? Security always precedes development. So in some places it's just like, well, it's not worth the risk to go to location X and try to do anything because we'll never get anywhere, right? In other places where security is there, um, it's the getting both local and governmental and like national people on the same page of here's the right thing to do, right? That's really, really hard. And that's where politics becomes the bottleneck, right? Because you've got lots and lots of different tribes, lots of different kind of ethnic loyalties, many areas where tribalism is still kind of the dominant ethos, and that's just tricky politically, right? And it's not even about what's the right thing to do on the land. It's about getting people on the same page so that the funding that comes in, or whatever resources are available, get invested in the right kind of thing to happen, right? After that, I think it's about prototyping, because if we're talking about land managers, getting sustainable land management means having sustainable land managers, right? People who know how to manage land such that rather than degrading soil and water resources, you're actually revitalizing them. Okay, that's not intuitive, and in most places it is not practiced. And so then it's, how do we create a land and water management system that's going to increase the wealth locally, right? And achieve those objectives. And for me, that's kind of the baseline of the whole regenerative concept, right? Is that you are increasing the wealth of the land managers while increasing these fundamental resources of water, soil, and biodiversity, right? Sometimes that's agroforestry in a very conventional kind of cropping sense, a farmer sense. And the best example of that is FMNR, which is farmer managed natural regeneration. The whole movement that Tony Renato was a leader of in Niger, and which has spread to, I believe, 14 different countries in sub-Saharan Africa. There was about a decade where Niger was the only African country seeing an increase in forest cover. And that was because of FMNR, where Tony Renato and his team taught people how to cheaply grow crops in an agroforestry setting. And it just made agroforestry take off. And another way to think of them is that they're like an African version of syntropic ag, right? So they're doing polycultures, and they're growing in rows of trees. In a lot of places, FMNR is the right answer. And it's growing quite well from what I understand. But in other places where you're dealing with pastoralists, then it's silvopasture, right? And establishing patterns of, here are the hay trees that we can grow, and how do we work these into the summer versus or wet season versus dry season grazing patterns. And that's really tricky stuff. So there's layers of barriers to this, right? Starting with security, and then politics, and then I would call it the political economy of actual land managers, right? Small scale farmers, villages, pastoralists who need to have these systems de-risked before they can implement them, right? Because farming and food production is a high risk, low margin activity, right? So if I'm a farmer and I've got 5 acres and I'm used to tending my maize and my sorghum, right? And I'm barely making it, and I really want to send my kids to school, and I need to buy new shoes for my 4-year-old. I'm not just going to willy-nilly accept some guy coming in and saying, hey, change how you farm, right? I farmed the way my dad farmed, who farmed the way his dad farmed, and this is what I know. And I'm not going to take the risk of adopting new practices unless you can show me that it's going to be better for me and not risky, right? Because if you just change what you do without knowing what you're doing, you lose the farm, right? And then it's collapse. So for the small scale landholders, right? For the farmers who are living on the economic edge of making it or not. These systems, you can't just ask them to adopt a new way of managing land, right? You've got to show them that they're going to make more money, that their family's going to be better off by adopting this thing. And that's where FMNR has succeeded so spectacularly. And that's why a lot of efforts have failed so spectacularly. Because the people who take the most risk in growing food are the actual farmers. Right. And you don't even get to that point until the politicians are allowing you to do what you want to do. Right. And you don't get to that point unless there's actual security. And you can trust that if you go and plant a forest, that it's not going to get cut down in 20 years. So
Yeah.
there's layers of things that need to be addressed and de-risked for an endeavor of that magnitude to succeed. And local culture and local ethnicity and local politics always play into it.
Yeah. Yeah. So whenever you approach a land restoration, you always have to think about the whole social economic aspect too.
If you don't, you're going to fail
Yeah.
spectacular, right? It doesn't make any sense to grow trees unless we address why people are cutting down trees in the first place.
Right. Cool. Well, it's been a super fascinating discussion with you. Ranged over a lot of countries and
Yeah. I mean, it's such an important thing to do. And it's so poorly understood by most folks. And so it's a labor of love.
yeah.
It really is. It really is. Yeah, no one's doing this that doesn't have their heart in it, because no one's getting rich doing it.
Right. Well, thank you for spearheading a lot of this and getting a lot of people excited with some of your, success stories like in Saudi Arabia. So I think it's inspiring to a lot of people.
I hope so. I
Yeah.
hope so. But thank you for having me on, Alpha.
Yeah.
And looking forward to seeing you in Iberia.
Yeah. Okay. Cool. All
It's
right.
going to be great.